The stream started.
You started?
Okay.
Hello, hello. Hello. Alright, hi guys. My name is Daniel. I am the workshop presenter for Create, as well as the 2018 acting president. What Create does is we aim to provide you guys with some skills, no matter what your background is, so that you guys can start making things for yourself. And so this is what these workshop series are for, besides all the other stuff that we do. So today is just going to be an introduction to electronics. So you don't need any background in electronics to attend this lecture, to attend this workshop. If you go past around, you'll see that there's a little demo of what we're going to be making today. Hey, at the back, is it working? Yeah? Yeah, so just wave your hand across it and then you'll see some lights magically turn on.
It's like outputting like only the corner.
I don't know how to fix that.
Just double check.
Try that.
Did you change resolution?
Yeah, I did.
Because it's still stuck. Can you see how it's only moving up?
Oh, I can't do anything about it. Yeah. It's okay. I can zoom in on it anyway. Okay. Yeah, so it'll be passed around. That's what we're going to be making today if you guys have the kit. Since we don't have too much kit, it'll be probably good to do it in pairs. But it'll be fine. You should be alright. Yeah? Alright, let's get started. So at the start, I'm just going to go through some very high-level understanding of some electrical concepts. We won't go too deep because the aim of this workshop is for you guys to do something practical. So I'm going to keep it short. I'm going to introduce some basic electronics components with an emphasis on breadboards, which is the main thing that we're going to be prototyping on. And we're going to make that circuit. So it doesn't really look like that because we're going to be making it on what we call a breadboard, but the functionality will be the same. In the dark, it'll turn on, so that's why you can wave your hand. We'll see how it all works. So the most fundamental thing that you got to understand is three concepts. All right, voltage, current, resistance. Have any of you guys heard these terms before? Probably. Way back, right? Yeah. Voltage is equal to resistance times your current. Right? I won't go into too much detail, but all you really need to do is think of this analogy. Okay, voltage is what's pushing your electrons, your charge, through an electrical circuit. It needs to be a closed conductor. Your resistance is what's preventing current from flowing, and amperage is what's actually flowing. Okay. Okay. Skip over that. So these are all the components that we're going to be using today. Resistors, variable resistors, light-dependent resistors. Okay, those are resistances where its ability to restrict your current in a circuit depends on the brightness shone onto it. That's the thing on the circuit that's being passed around. If you hover over that, that's what's going to cause the change in the light intensity of your light-emitting diode, which is the LED. We're also going to be using transistors, which I'll cover in a bit, and breadboards. That's it. Just 1, 2, 3, 4, 5, 6 components. Okay, so resistors, their only purpose is to limit current in a circuit. We're going to look at that a bit more later as to see why you need them. Current is the flow of electrons through your material, right? If you don't have a resistor and you get too much current, if you think about electrons flowing through your material, electrons colliding with the atoms of your material, you produce friction, you produce heat. So if you don't have a resistor, you produce a lot of heat in your wires to a point where it's called a short circuit and explosions, heat. You'll see that later. Okay, so resistors are in units of ohms. The higher your ohms, the more resistance it is, right? So what we'll be using today typically will be a 220 ohm resistor. They're just values, okay? So once you do a lot of electronics, you'll know that 220 is what you normally have with a resistor. In the little packs that you got, you can see resistors that look like this top one, and they'll have bands of colors on them, okay? The color bands allow you to determine the actual resistor value. That's all, okay? There are other ways to do that because it's quite inconvenient through a device called a multimeter, but we don't have those today for now. Okay, so I already went through light-dependent resistors. They're resistors that resistance changes with the light intensity shone onto it, okay? Just by this diagram, okay? So there's two types. One that its resistance drops with light intensity and one that increases with light intensity. The one we're using, the one that you see in your things, looks like the picture on top, and it will have that sort of shape. So the light intensity, so if you shine light onto it, the resistance decreases. Okay. Light emitting diodes, they're your lights. Okay, simple as that. We'll talk about this long lead, short lead thing later, but yeah, okay. Bipolar junction transistors, BJTs. I think this will be more, the electronics in it is quite difficult. In fact, there's actually a whole course on it at UNSW, so I won't go too in depth, but if you look at this picture here, if you supply a positive voltage, so like a push at the base here, it will allow current to flow from the collector to the emitter. So as long as you put a positive voltage here, you have current flowing this way. And vice versa is also true. If you don't apply a positive voltage here, you don't get current flowing through here, okay? All right, the breadboard. Okay, this is what a breadboard is in electronics. Have you guys used these before? A few of you? Okay, most of you probably not. So this is what a breadboard looks like. Now, if you think about electric circuits, right? You have all these different components. You have wires, resistors, all sorts of things, motors. How are you going to connect them all? Okay. Are you going to get the leads and twist them together? Or are you going to melt metal onto it and hold it in place? You see, both of those ways aren't very convenient for us. If you once you put them in place, like, if you think about the first one where you're coiling them, what if you have something that's really hard to coil? Then you're stuck, and it's not a good connection. If you have the second way where you melt two metals together to put it on, then that's a permanent connection. So you don't have any ability to experiment. So this is what breadboards are for. It's also called a prototyping board. The reason for that is because all you need to do is plug components in, and the way you plug them, you can create circuits just on here, and then you can take them out and use your components again. So breadboards are essentially the first place you do to experiment with circuits. That's what we're doing today. So as you can see, I've circled some parts of your breadboard. You have a mini one in the kit, which looks like the red one but white. So essentially, behind this breadboard, all it is a bunch of steel plates like that. Steel plates. So that means all of those horizontal rows are actually connected, electrically connected. So if you plug two components in there, they will be connected via this metal bar. And if you have a medium breadboard, then you also have these side rows that are all electrically connected. I think I have a picture on the next slide. There we go. Okay. So horizontal holes are all linked together, but not across the middle divider. and you have that sort of structure. Okay? Any questions on breadboards? No? All fine? Okay. Okay, so this is how you would generally set up a circuit on a breadboard. Okay? Is that clear enough? Is that good for you guys at the back? Can you see the diagram? Not too bad? Yeah? Okay. See if I can make it a bit bigger for you. No. Bit better? Okay. So the circuit on the left and the circuit on the right. So the picture on the left is the representation of how you could assemble it on the breadboard. The circuit diagram on the right. So okay, you have 5 volts, right? Going to an LED. Okay, look at all these links. All of these highlighted parts are one link. They're all electrically connected. Okay, so you got wire going there, wire going there. This is going through the LED. Okay, these two are connected because they're in the same row of your breadboard. Cross the resistor into the switch which connects it internally, and that goes down to ground. Okay, and that follows the structure. One part. Okay, no problems there. These slides are available on the Facebook link as well, if you guys want a copy of it. Okay. Okay, here's the warning I was talking about. Take a look at this picture here, okay? What you notice is that here's an analogy with voltage, resistance and current that you've probably heard of, okay? Think about you're on a road, okay? Cars are the things that are going to flow your current, and the width or the amount of lanes on your road is sort of like the resistance. Okay, the more lanes you have, the less traffic you have, and so the more cars can flow. The less lanes you have, the opposite, you get a traffic jam. Okay, now in the case of a short circuit, it's sort of like you don't have any resistance at all. You have, okay, think about you in a traffic jam, right? What are you gonna do? Are you gonna stick in the lane that's packed, or are you gonna go into a free zone? You know, it's just gonna go into the free zone, right? So if you think about this, which is a short circuit, would you rather go through the wire or some lamp thing? You're gonna just go through the wire. So you bypass your load, and then all this energy has nowhere to go. So where does the energy go? It dissipates as heat. So short circuit, your circuit gets super hot, you start melting wires, you start melting components. Okay? So this is exactly what you want to avoid when you start building circuits. Okay? So practically, how does it happen? So this is a very, very, very common error. Okay? Take a look at both sides of the breadboard, both pictures. On the left, you have the LED connected, or some light bulb, doesn't matter, such that both terminals are on the same row. Okay? This one, the terminals are on different rows. Okay, so let's trace it, right? Positive into here. But now there's actually two connections here. There's an invisible connection between here and here, because of the underlying layout of the breadboard. These rows are electrically connected through the metal. So in fact, when the electrons reaches here, is it going to go through a light bulb which is resistive, or is it just going to go straight through the conductive metal? It'll just go straight through the conductive metal, and then back to your power. So essentially, there's nothing to dissipate the energy except heat. So you get heat. This is called a short circuit and you don't get light. You look at this one, the electrons can only flow through your light bulb and then back to your power supply. There's only one way. So this one works. Okay? So this is the error that you could make in your current circuit, in this circuit here. But because we're using very low voltages and very low power, you probably won't see anything heat up. So it's completely safe. But your circuit won't work. I'll be going around to check, probably some people at the back as well, if you have any problems. So now, let me introduce you to the circuit. Okay? Okay. Let's see how this works. I'll zoom up on it a bit. Okay. All right. Okay. This is the diagrammatical representation of a battery or power supply. Okay, so that's a battery. Now, so the longer lead is your positive terminal, and this is your negative terminal. And the negative terminal is actually connected to ground, which is 0 volts. Okay, 0 volts, 5 volts. This is where energy is coming through, and that's where it should end. So you trace it. And then there's two paths for the electrons, okay? Two paths. Either you go down this way, or you go through the LEDs, okay? LEDs, resistors. The resistive symbol with an arrow is a variable resistor. So you can change the resistance here. This, do you see the squiggly thing? If you looked at the demo I showed you, you'll see that the light-dependent resistor has the squiggly thing on it. So this is the light-dependent resistor, okay? Now, let's look at the scenario where there's a lot of light, okay? So that means this light-dependent resistor would have low resistance, okay? So this light-dependent resistor is one where it has low resistance with high brightness, okay? So imagine that this has low resistance. So to the point where it's just a short, so it's just a wire, okay? Imagine this is just a wire for now. So if you see electrons, and then they have two paths, they can either go here or go through here, okay? Once they get to here, because of this is a short, there's not going to be any flow into here, okay? So that goes straight through. Now, why does this mean that the light doesn't turn on? Well, if there's no flow into here, that means we don't get anything here. Now, I gave you a quick rundown of Bjts, and when there's no activity here, so no voltage, not a high enough voltage or no current, you're not going to get any current going through here. So if there's no current through here, then you can just look at it as if it's an open circuit. And if it's an open circuit, you're not going to get flow through the LEDs, so they can't turn on. But once you hover across this enough, then this is a block. So then electrons can't take this path anymore. So then they go through here, they turn this on, and then it allows current to flow. So that means the LEDs turn on. That's a rough analysis of this. Does that make sense? Cool. Okay, so I actually had some extra pictures to show that. Okay, I made a bit simpler diagram. This is the one that's on there. Seems to work a lot better. And yeah, this is what we're going to be making together, okay? Okay, do I have... So you guys only have the mini breadboard, so it's going to be a bit harder. I don't think there's any wires in them either. But I'll be assembling it through a webcam, so you guys can see what I'm doing. Or... yeah, let's do that. Okay. Okay, that was it for the theory. Now we're just going to go practical. Okay. So just get set up. Are you guys working in pairs or something? Because, yeah? Okay. Let me give me a sec. Okay. Yeah, it's really small. Does anyone know how to get the webcam up? Actually, it might be easier if I just do this. Okay, you guys only have a small amount of space to work with, right? Just this tiny breadboard. So in your kit, you'll also see a little green thing. So this thing's called a Breadboard. What this is used for, because you see that if you put components in, they don't stick in. These are for more permanent circuits. So our next week is actually a soldering workshop where, remember one of the ways I told you was to melt, or not to actually have a permanent connection. And essentially we use a metal alloy called solder. We melt that onto components to solder them together. So in next week, what we're going to be doing is placing components in this Breadboard, like so. And then on the back, we're going to melt solder onto these connections so as to make a permanent circuit. So that's this thing we won't be using this week, okay? But yeah, it's called a Breadboard. Okay, and then you also see like a coil of metal, like so. Okay, that coil of metal is the solder. It's the metal alloy that you're going to use to melt. This thing has a melting point of about 350 degrees, so much lower than an average metal. So that's why you can melt it. Okay. Besides those things, we'll be using, okay, so this is your breadboard, right? Now, your battery clip is about 1/4 of this breadboard. So what you'd probably want to do is just place it right at the edge somewhere. Okay? You can see on the screen. Just Just make it take up right at the very corner. Okay. Okay. Now just note where your negative and positive terminals are. You don't need to put the battery in just yet. Just make space for the battery clip. On the clip at the top, you'll see that there's a positive sign. So that's the positive edge of your battery. Okay. Now think about your circuit, right? So that positive edge, the best thing that you probably do is put the positive edge on the very top row to minimize the space that it takes in the following setup. So that whole row is electrically connected, right? Now you want to be able to make this. Now look at where the positive leads to. The positive is connected to one side of a variable resistor and another side of, and on that same row it should be connected to one end of a 330 ohm resistor. Okay, now in your little pocket there should be a orange brown. Yeah, orange brown. Do you guys have any of that? Or maybe a red brown. Do we have helpers at the back that can go around? If you guys need help in finding some components, just raise your hand. But expect to find either orange brown or red brown. Oh, these blue ones are perfect. Just use the blue ones. Yeah, just use the blue ones. Okay, so the blue ones are fine. The blue ones are 220 ohm, which will be just fine. 330, 220, it doesn't matter. So those are fine. You'll notice that those are probably all you have, but you'll probably have these three bigger blue things. 3 big blue rectangles, right? These are 10K each. So the max, so these blue things, they look like this. They're called trim pots / variable resistors. So these variable resistors vary from 1 kilo ohm to 10 kilo ohms. And you'll notice that these have 3 legs, right? So one leg is I think it's the middle one. It's the one that varies between, the one that actually used to, if you see the gold knob, if you twist that gold knob, it will change the resistance between two of the pins, the middle one and either side. But if you use just the 2 outer pins, then it acts as a 10K resistor. So we'll be using that. So don't worry if you don't have any 10Ks, these work just fine. Okay. Right, now think about your circuit, okay? If you think about the circuit, you have a 10K connected in the same row, right? This 10K resistor is connected in the same row as the positive end of your battery source, okay? So in the same row where you have the positive supply, you want to put in one of these blue, the big blue rectangles. You want to put one of these legs in the same row, okay? Now, which leg? You can pick any of the 2 outer ones, so not the inner one. Can you fit that? In fact, you can ignore the middle leg. So what I just did is I folded the middle leg up, so you only have 2 legs, and just plug it in. Okay, so plugged it in like that. Okay. Now with your resistor that you have, okay, so that's going up to the first row. Now notice, so the way you're going to build this, right, is completely up to you to experiment. But just think of these wires as the legs of your components. The second leg of your variable resistor is not connected to this resistor, to the other resistor. So just think of wires as the legs of your components and how you got to assemble all this, right? I'm going to be building it here. Have a go at building it yourself, because that's the whole point of this. If you have troubles, just raise your hand and then we'll hit you up. Oh, now with LEDs, just look at how I drew them, right? You'll notice that there's an arrow and then that sort of horizontal line, right? So these are your LEDs, so your lights. Now notice that there's a flat edge there, right? So that flat edge can actually be seen on your actual component. If you look at your two legs, if you actually look at the red cap or the blue cap, you'll see that one side is actually flat. So that flat side is the same as that horizontal edge in the circuit diagram. There's a connection and a connection, okay? So the arrow on it, so that means this leg. So that's that one, right? Now, the other leg represents this point. Yeah? Now, we still need to take into account this one. So, but the end of this one cannot go to the same point. So this one should go to a different row. So place that in a different row. So if you get your blue resistor, that's actually in one of the legs, right? But the other leg is going to go to this end. But just because after this one, there's more components, right? So we probably don't want to use this space. So maybe, so what I did was that space. So knowing that, so just think of the legs of the components, think where they can Connected to the same leg as the variable resistor, and is also connected to
So you'll notice on this picture that you have a 22k ohm here, right? Now in your circuit, in what you have given, you don't have a 22k ohm, but you do have 3 of the pots, the variable resistors, right? And they're 10k each. Now if you cascade those, if you cascade 3 of them, you have 30 kilo ohms. Does that make sense? So each of the blue pots, the blue rectangles, they're 10 kilo ohms each, yep.
But we're using a 10 kilo ohm at the top.
Yep.
And we also need 22, so
yep.
we need 4 of them. 4 blue ones.
So,
we need 4.
So each of them is 10k, right?
Yeah.
So 10k, 10k, 10k. That's pretty much the setup, yeah.
Yeah, but that's the total is 32 kilo ohms.
Yeah. Oh, so 32 and 30, it doesn't matter.
Oh.
Yeah, yeah. So with circuits, it can have a rough estimate. Just like how the 330 can be replaced with the 220. It'll still work. It'll just mean different variables of current, but optimally it'll still work. Yeah, so I'll show you guys what I did for the 22. So on this, in my picture, if you guys can see it. Okay. You don't have to assemble it the same way as me, okay? So, but the thing is that one leg of the pot is connected to the other leg is connected to another leg, etc., etc. So, I'll show you this on a diagram, what I mean. Yeah. Okay, so resistors in series compound, so their values add. So the 22 Ka can be approximated to 210Ks in this sort of setup. Okay? And then obviously you have the other 10K on the top here. This one. Okay? So that's your variable one. But from experimental, you don't even need to use the function of the variable resistor. As long as you have 30K, it should work in this ambient environment. That's what the the demonstration one had. So it actually didn't use the variable setup of the pot, but it's there for you if you want. Okay. The other thing is that you see this NPN transistor, right? This, you need to know which legs is what. So to do that, if we scroll back to the, actually, I have this here. Okay. All right. So if you hold, so the transistor that you have is the black thing in your kit. Now, if you hold the flat side, if you make the flat side point towards you, then the one on the most right of what you see is the emitter. Okay? So just look at this picture. If you hold the flat side towards you, the one on your most right is the emitter. And the emitter is the one with the arrow. Okay? So literally, if you look at these diagrams, with the LED, on the LED you saw the flat side, right? And that corresponded to the flat side in the picture. This is the same. So the flat side going that way, if you make a point that way, then the one on the bottom is your emitter. The one in the middle is your base, and the one on the top is your collector. So I'll just leave these two pictures up here, and I'll continue going around and helping you guys. Okay. If you guys need 1 or 2 wires, just raise your hands and I can get some for you. Okay.
Yeah. If you guys want like a circuit just to check, like if everything's in place, you can just ask for this as well. So I suggest let's just take out just use one LED. If you guys want me to check the validity of what you currently have so far, just raise your hand as well. Yeah, we can't see, So if you're not working, you might want to help people around here as well. You made it work. Oh, This one, nice. So I might take a picture of that. It was just
This one for a minute. What is the